Okay, so learned from the last video that I definitely need to write some things in beforehand because holding the paper with my wrist is not working out great. So for number 2, we are going to name the following. You're going to name a circle, minor arc, major arcs, and semicircles. The minor arc, you're going to name 4 of them. Major arc, you're going to name 3. Semicircle, you're going to name 2, and up at the top circle, I forgot to mention there's only 1. So just to review, circle, use your center point. Minor arcs are 2 points, shortest distance between those points. Major arc is 3 points with endpoints and a point in between. And a semicircle is named like a major arc. So, give you some time to look at that image. Please go ahead and pause it. I will pause for dramatic effect, but I will start filling in possible answers in 20 seconds. Okay, give you a little bit more time. So circle, you start from the middle point, so this would be circle S. Minor arc, you only have to name 4. I'll name a few more. We have NG, NI, NR, IR, IP, PR, PG, GI. Now remember, all of these could be switched in the arrangement of the letter order. For minor arc, there is not a big concern as far as what order you're listing them, just because there will always be 2 endpoints and the shortest distance between them. Major, list a few of these. NPI, IRG, RPI, PGR, GPN, GRI, RGN, and PGI. Okay, now the order on those letters do make a lot more difference, so please pay attention to that. The endpoints can switch. And semicircle, we only need to name 2. I will list a few more options. NGP, NRP, RPG, and RNG. Those are some options, so hopefully that went well for you. The next vocab we're going to deal with is a central angle. A central angle is an angle whose vertex is on the center of the circle. Remember, vertex is the point at which the angle is created. So, for example, angle JKL is a central angle. Now, what do we know about angles in a circle? Well, we've discussed this before, but the theorem, or there is a theorem that states and proves there are 360 degrees in a circle. The corollary to that fact, which just means a fact on a fact, there are 180 degrees, or half of 360, in a semicircle, or what some people refer to as half a circle, but the vocab word would be semicircle. And last but not least, a theorem that would be new to you would be the measure of an arc is equal to the measure of its central angle. The measure of an arc is equal to the measure of its central angle. So for example, if I were to say that this JKL, the central angle, was 120 degrees, then I would say that the arc created from that central angle would also be 120 degrees. Okay, and just to be clear, this is the measure of an arc. Right. For the next example, we're going to find the measure of the following. Don't worry about that stuff down there. Okay. Now, based on this drawing, give you some time to write it. All we know is this is 22 degrees and we have this image here. Now we want to remember what that means. So hopefully you remember that means that this is 90 degrees. Okay. Now we want to find the other pieces of information. So if this is 90 degrees, then we can figure out the rest of the information from remembering a straight line and how much the circle equals. Now, a straight line or a semicircle is 180 degrees. So this is 180 degrees. So if I know this is 90, that's 22, then the difference would be what's left over. So 180 minus 90 minus 22 gives me 68. So this is 68 degrees. Okay, now that also could be true on this straight or semicircle. Now, what vocab word tells me that those angles would be congruent? Okay, vertical angles. And then last but not least, we have this angle. There's two different ways you can find it. You could either subtract all of these angles from 360, or again, you could work with your semicircles and see if this is 68, then this would have to be what's left of that semicircle. So 180 minus 68 leaves me with 112. Okay. So what I want you to do now is to find the measure of the following. So remember, based on that theorem, that the central angle is the measure of the arc. So the measure of AB is based on the central angle. So the measure of the measure of arc AB is 90 degrees. Okay. Now what about the measure of arc AC? That just simply means I'm going to have to add. Well, what's 90 plus 68? Well, that's 158. So go ahead and find the next four, and I'll check back on the next video.